A term is a really important algebraic vocab word that has to do with one kind of number, or one number and a variable, or one variable. So here right now you see that I have a list of different terms. 2 is the first term, 4 is the second term, 6 is the third term, 8 is the fourth term, and I'm looking for the fifth term. So term means like one piece of a larger either expression, or in this case, sequence. A sequence is another important vocab word. It looks like this, and it means a pattern of terms that all follow the same rule, but it's not just like one of those numbers, it's the whole thing, the whole list that follow a pattern. So here we have 2 and then we have 4. We can check with an additive or a multiplicative. 2 plus 2 is 4, 2 times 2 is 4. Check the next one. Plus 2 times 2. 4 plus 2 is 6, that works. 4 times 2, ooh, that's not 6. So this is not a multiplicative sequence, it's an additive sequence. So the sequence is the whole thing, the whole pattern, and the term is the one specific number. So if we have the sequence 2, 4, 6, 8, the fifth term would be 10, because we are adding by 2's. The reason we need to know what a term is when we get to simplifying expressions or combining like terms. Even in that vocab word or phrase, like terms, we're looking for different terms that have something in common. So here in this algebraic expression, I have one term right here that is 3x. I have a second term that is positive 2y, and I have a third term that is negative 7. Notice that I included every operation symbol. There's nothing left out. It's not like I said 3x and 2y and 7 and I left out my operations. They're included when I circle my terms. That is because we need to carry those symbols with us, the minus and the plus symbols with us, when we start combining like terms. So here, if I asked you how many terms there are 3 terms in this expression. 3x is one of them, positive 2y is one of them, and negative 7 is the third one. The reason we need to know what a term is and how to separate it, including its symbol, its operation in front of it, is for problems like this. Here we have 3x plus 2y minus 7. This is the expression we were just working with, but I added 2 extra terms, plus 3y plus 2. Okay, why do I care about terms? Well, because that's kind of a long expression to write out. And I could simplify this. We can remember from fractions that simplify means make it more simple. Don't make me write out this whole long thing if I could say it in a shorter version. So we need to look for like terms. Like terms are terms that have something in common. They look alike. So think about this. Maybe you and your brother look a lot alike. That means that you share some kind of quality that people can look at and recognize, hey, there's something similar about the two of you. Same thing with algebra. I can look at this 2y and say, hey, there's something similar about 2y's and 3y's. Y is my similar feature right there. When we're looking for like terms, we could be looking for straight up numbers. No variables, just a number. Ooh, hey, check it out. Negative 7, positive 2. Those are straight up numbers. We could be looking for just a variable. Maybe we see x all by itself. That's a term. We could be looking for a number that is multiplied or divided by a variable. 3x. number, numeric coefficient, times variable. Or we could be looking for multiple variables that are multiplied together. Sometimes you might see x, y. That is its own variable that I could not combine with anything else in this expression because I don't see any other x, y's. You might also see things like x to the power of 2. That's a different shape than an algebra tile for just plain x. So those look kind of similar, but not similar enough to call them like terms. So what do we do when we've found our like terms? Let's start by circling off my exact terms. I want to make sure that I keep every symbol, every number, every variable in some circle. Here's 3x. I'm not going to leave 2y by itself. I'm carrying that symbol before it. I'm not leaving 7 by itself. I'm including that minus sign before it. 3y must have that plus in front of it, and 2 must have that plus in front of it. Just coming back here, just because there's an exit there, a variable, does not mean that our rules are different. If we just saw the number 3, we would know that that has to be positive because I don't see a negative sign. You don't have to have a plus sign in front of it for you to know, oh, hey, that's positive. So this is actually like a positive 3x. Okay, now let's regroup. Maybe you want to use different color highlighters. Maybe you want to use different symbols, like circles around some things or boxes around something else. Maybe you want to use colored pencils. But let's take a look. This 7 is just a number, -7, no variable. Same with this 2, no variable. Positive 3y has something similar going on with 2y. Y's, y's. Doesn't matter if they're positive or negative, got some y's. This x over here, all alone, no other x's in this expression. It's not going to combine with anything. So let me rewrite. I have 3x plus 2y's plus 3y's minus 7 plus 2. Still not done, but now they look like they're closer together. Okay, 3x's is just 3x's. I can't combine it with anything. If I have 2y's plus 3 more y's, how many total y's is that? 1, 2, 3, 4, 5. This is positive 5y. The nice thing about combining like terms is you can call that positive 5y or you can call that plus 5y. When you read it, you'll read it as a plus, but just putting that positive or the negative sign in there is enough to make sure that you have all the information you need. And if you call it positive, that's great. When you read the whole expression, you'll probably say plus. Either way, you're correct. Over here, I have -7 plus 2. We are going to be running into a lot more integers, so let's remember our integers were charts. If you are adding, you can use this. If you're subtracting, you have to do keep change opposite to change it to an addition problem before you can. All right, I got 7 points for the negative team right here, 2 points for the positive team. Which team wins? Negative. By how many points? That means winner minus loser. 7 minus 2 is 5. And my answer is negative, so -5 right here. When you read your final expression, we have 3x, positive 5y, -5, or if you want to read it as an algebraic expression, 3x plus 5y minus 5. You don't have any more similar or like terms to combine. You have simplified this whole expression from 5 terms down to 3 terms, and now it's a lot more simple when you need to go then plug in and evaluate, oh, if x equals 3 and y equals 7, what's my answer? You don't need to be plugging it in all over the place. You'll only need to plug in 1 time for x and 1 time for y.